Hello, my dears, and welcome to the lesson on geometric mean, Chapter 8, Lesson 1 in your book. Let's begin. We have been talking about right triangles for a while, but they have a special relationship when you draw the altitude within them and create three total right triangles. So looking at this triangle we are given triangle UWV, which is a right triangle. And if you notice, WZ is the altitude, which creates two smaller right triangles. Let's separate them. We can obviously start with the main right triangle, we're going to make this one V and U. Let's pull out the medium-sized triangle. The right angle, as you notice, is now Z. So here's Z, and this ZU corresponds with WU. And of course, V is here. Then we have our smallest triangle. The right angle is still at Z, and the corresponding part to WU, ZU, is WZ, which puts V up here. We have now created three similar triangles, which means you can write a similarity statement. The similarity statement would be triangle WVU is similar to triangle, well, remember to match up your parts. Angle W is congruent to angle Z, angle V is congruent to angle V, and angle U is congruent to angle U. Let's make that similar to triangle ZVW. So before we move on, you need to make sure you can pull apart the triangles as well. So on this next one, I want you to pause the video, give it a try, and then check back in to make sure that you did it right. So pause the video now. Okay, let's see how you did. When you separated the triangles, this is what you should have gotten. So double check to make sure you have drawn them the correct way, or at least labeled them the correct way, the corresponding parts. And when you write your similarity statement, this is what you should get. Because we need to know how to do this in order to use the geometric mean. And consider the proportion A over X equals X over B. In this case, the means of the proportion are the same number, in this case, X and X. And that number is the geometric mean of the extremes. The geometric mean of two positive numbers is the positive square root of their product. Remembering that with the square root you get positive or negative, but for the geometric mean we only want the positive. So the geometric mean of A and B is the positive number X such that X equals the square root of AB, or X squared equals AB. Now you might be going, what? So let's break it apart. Let me bring down the proportion from up above. Hopefully you remember that in order to solve a proportion, you have to cross multiply. So when we cross multiply, X times X is X squared. A times B is AB, which is how they got this here at the end. In order to get X by himself, we need to do the square root, to where we get X equals the square root of AB. So how are we going to use this? Well, first we need to practice the math part of it. So we want to find the geometric mean of 4 and 25. You can let X be the geometric mean. So let's set up our proportion. If X is the geometric mean, we need to have 1 on the bottom and 1 on the top. Because remember, it is the product of the extremes, the product of the means. So now we have our 4 and 25. Cross multiply to solve. X times X, 4 times 25. Now we have to take the square root. The positive square root of 100 is 10. So the geometric mean of 4 and 25 is 10. So now you're going to try one on your own. Find the geometric mean of 5 and 30. Remember, let X be your geometric mean. So at this time, please pause the video and give this one a try. Alright, let's see how you did. If you let x be the geometric mean, you should have set up your proportion in this way. When you cross multiply, you get x squared equals 150. Then hopefully you remembered to take the square root of both sides. Uh-oh, 150 is not a perfect square. So did you remember to simplify your radical? I hope you did. Let's break it down over here. Hopefully you recognize that 15 and 10 are factors of 150. 15 can be broken down into 5 and 3. 10 can be broken down into 5 and 2. So when we write down all the prime numbers, you notice we have one happy couple. The happy couple goes outside, and we still have to do 2 times 3 inside. So hopefully you simplified your radical, and you got the geometric mean of 5 and 30 is 5 square root of 6. If you got square root of 150, that's great, but now you just need to practice on your simplifying the radical. So now let's start applying our geometric mean to our right triangles. This is where we're going to use them. So if you notice, our triangle here looks very similar to what we were looking at earlier. They have now labeled all the different parts of the triangles. Down here, we can compare the legs of the big triangle ABC, B to A, is comparable to Y to H, which is also to H to X when you break apart the 3 triangles. If you need to separate the triangles, they did so here. So we also know the hypotenuse to leg A compares to the hypotenuse of the medium triangle B to H, which also compares to the hypotenuse on the smallest triangle A to the leg X. Notice we do create a geometric mean in all 3. We're going to use this in order to find missing side lengths. So let's take a look. This is from your book. Make sure that you have this written down in your notes. Now you might be asking, where do these equations come from? Well, it comes from the proportions you saw on the previous slide. But let's talk about each one. This first one says the length of the altitude to the hypotenuse of a right triangle, so in this picture, H, is the geometric mean of the 2 segments of the hypotenuse. So could you set up your proportion from this? Absolutely. Remembering that the altitude is the geometric mean of the 2 parts of the hypotenuse. So when you cross multiply, we have h squared equals xy, which is exactly what they have over here. So if you cannot remember these equations, hopefully you can find the geometric mean on the triangle and set up a proportion and solve from there. That is perfectly okay. Let's take a look at the second corollary. It says the length of the leg of a right triangle, so A, is the geometric mean of the entire hypotenuse C and the adjacent part right next to it, X. So let's set up that proportion. The leg is the geometric mean of the hypotenuse and the adjacent part. So when we cross multiply, we get a squared equals x times c. Notice that's what they have here. So now take a moment and try to set up the geometric mean using B as the leg. Hopefully you recognize that B is the geometric mean of the hypotenuse and the adjacent leg. And when we cross multiply, we do get b squared equals y times c. So is it okay to memorize these formulas? Sure, but do you have to? Not if you understand what the geometric mean is. You need to understand what these two corollaries say about the altitude being the geometric mean of the 2 parts of the hypotenuse, and the leg of a right triangle is the geometric mean of the hypotenuse and the adjacent segment. So keep this in mind as we move on. So here we have missing values, x, y, and z. We're going to use the previous corollaries in order to help us solve this. So let's find x first. Notice x is a part of the hypotenuse. Well, we don't know his adjacent leg, but we do know the altitude. And if you remember, the altitude is the geometric mean of the two parts of the hypotenuse. And by doing this, when we cross multiply, 36 equals 9x. Divide both sides by 9, and you get that the value of x is 4. This gives us a lot of information. This gives us the entire hypotenuse, which is 13 units, and it can also help us find y. So you notice y is the leg of a right triangle, which we know that the leg is the geometric mean of the entire hypotenuse and the adjacent leg. So in this case, you had to find x before you could find y. So now when we cross multiply, y squared equals 52. Solve for y, we take the square root of both sides, and we get y equals, make sure that you factor this out, and you get 4 times 13. 4 is a perfect square, so you should get that y is 2 square roots of 3. Now try finding z on your own. Pause the video and set it up and find z. Let's see how you did. You notice z is the leg of a right triangle, so we know that he is the geometric mean of the whole hypotenuse and the adjacent part of the hypotenuse, which is 9. Cross multiply, z squared equals 117. Take the square root of both sides, and you get z equals, well, you got to break this one down as well. This one breaks down to 9 and 13. We notice 9 is a perfect square, so z is 3 square roots of 13. So let's take a look. A surveyor positions himself so that his line of sight to the top of a cliff and his line of sight to the bottom form a right angle as shown. Here's our surveyor. He's looking up, he's looking down. Creates a right angle. What is the height of the cliff to the nearest foot? So right now, I want you to think about what do I need to do in order to find the height of the cliff. Hopefully you noticed that I have two segments here on my right triangle. I need to find this missing piece. So now I want you to notice you're given the altitude, remembering what we learned about the altitude in a right triangle. So now pause the video and try solving for this question. Let's see how you did. Hopefully you remembered that the altitude of the right triangle is the geometric mean of the two parts of the hypotenuse. So this is where we're starting. When you cross multiply, you get 28 squared, which is 784, equals 5.5x. Solve for x by dividing by 5.5, and we get that x is 142.5. So now, how do we find the entire height of the cliff? Well, we got to add the two parts that we now know. And by doing so, hopefully you got 148 feet high. So that is how you can use geometric mean in order to find missing measures. So now I want you to practice on your own. I know this is new and I know this might be hard, but you have your notes written down and you always have this video to refer to. So what you see next, this is the worksheet you're going to do. Please do not write on my sheet. It's not Joe's. Okay? This worksheet is due at the end of class. The answers are on the back. So remember, in order to receive full credit, you must show work. But remember how we wrote that similarity statement. We pulled the triangles apart and drew 3 similar triangles. That's what I want to see on your work that you're going to turn in to me. Remember, this paper is due at the end of class, so you have no time to waste. You may work together, but do not copy. You really need to make sure you understand this concept. One last thing. Please remember to bring your book the rest of this week, as we will need them in class, and you know how good you are at sharing. You've done great. Keep it up.